Alright, hello everybody. We're going to get into the notes for 8.3, 8.4, and 8.5. There's a lot to cover. 8.3 deals with trigonometry, which is really the study of triangles, okay? And one of the things that you're going to learn that's going to come up in your other math classes are these trig ratios for sine, cosine, and tangent, all right? Um, Especially for right triangles, okay? Um, and the sign of A, capital letter, means the degree or the angle. And so this trig ratio means the sine of A is going to be the opposite side from that angle over the hypotenuse, okay? The cosine trig ratio, cosine of A, is going to be the adjacent side. So adjacent means next to. So again, from angle A, the side next to A is this side B over the hypotenuse C here. All right. And tangent is opposite over adjacent. So the opposite side over the adjacent side. Okay. So there's this mnemonic device called SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right? You're going to have to know this, all right? Now, again, it depends on what angle you look at, right? Like here, for instance, if you look at angle B, the side opposite from this B is this side right here, little b, okay? So the sine of B would be little b over the hypotenuse C. So it all depends on what angle you look at. Okay. By the way, this is not, we don't call this tan or cos or sin, right? These are just abbreviated ways to say those words. So sine, cosine, tangent. So here as a quick example, all right, sine of D. So meaning from D, sine is opposite over hypotenuse. So where is the opposite side? It's 20 over 29. All right. And since it's fractions, we're not going to use decimals. We're going to leave it as simplified fractions. So if it does simplify, then it simplifies. Okay. And then you do sine, cosine, and tangent. All right. Sine of E. Now from the perspective of E, right, the side opposite is 21 from E over the hypotenuse 29. Okay. Now why don't we do sine of F? This is something you'll get into a pre-calculus, when you take that class. But if you do sine of F, well, what's the side opposite of it? It's just the opposite. It's the hypotenuse, right? So we look at the acute angles, the non-90 degree angles, all right? So yeah, take a look at these ratios here. Okay, notice that I skipped example number 1. Okay. When you solve these equations, all right, we're going to use algebra skills, okay? We're going to do some cross multiplying, or like in number 4 here, to solve for x, we multiply by 12 to both sides, right? You can put this into the calculator, and it says you have to be in degree mode. So if you're using a graphing calculator or just any calculator, make sure when you go to mode that it is in degrees, okay? So here, this one, I thought I would go over it with you, okay? You are asked to solve for side C, all right, from 41. Now, the thing is, since we know a triangle adds up to 180, we can technically figure out what this angle is, and I might do that after this example, okay? And so from 41, right? Okay, well, from 41, where is the 19? It's opposite from it, right? We know this is the hypotenuse, but we don't know that length, and you're asked to solve for C. Well, where is C compared to where angle A or 41 degrees is? It's next to it, or it's adjacent, okay? So since we're not figuring out the hypotenuse, okay, well, I have opposite, and I have adjacent, which trig ratio deals with opposite and adjacent? That's going to be tangent, right? Because tangent is opposite over adjacent. So my setup here is tangent of 41 degrees is equal to the opposite side 19 over C. Okay? So now if we solve for C, right, I'm going to multiply by C on both sides. So I have C tangent of 41 is equal to 19. And since I'm solving for C, I'm going to divide by tan 41. Divide by tan 41. Okay. All right. Now in your calculator, that's going to be 19 divided by, when you press tan in your calculator, the parentheses automatically shows up, right? And then you're going to close it and hit enter. Okay. So again, it depends on what you have and from what angle. That's what you got to know, SOHCAHTOA. Okay. And so in this example, okay, you are given the 64, and again, where is 10? And it looks like we solved for x first, right? Doesn't really matter, okay? Opposite and adjacent, so that's why we use tangent. For solving for y, okay? Notice y is the hypotenuse because it's across from the 90-degree angle, all right? And so the sine of 64 opposite 10 over the hypotenuse, that's why we use sine, all right? Because it's opposite over hypotenuse. In this example here, take a look at what we have. From the angle 37, adjacent and hypotenuse, so we ask which trig ratio deals with adjacent and hypotenuse. All right, going back a few slides, that's cosine. All right, so here's my setup. Cosine of 37 is equal to adjacent x over 14, the hypotenuse. And since we're solving for x, we're gonna multiply by 14 on both sides, okay? And then you put that into your calculator. All right. I would suggest doing it in this order: 14 times cosine 37, because what I've seen some students do is this: they do cosine 37 and then times 14 and then close it. That's not correct. Okay. If you're going to do cosine first, then, like I said, the parentheses pops up in your calculator automatically. And then if you do it this way, you have to close it and then times 14. Okay. But I suggest doing it in this order right here. All right. Take a look at, so sometimes you have to solve for the angle. Okay. When you solve for the angle, you have to use the inverse. All right. It's going backwards. Now you're solving for the actual degree measure. And so the way you do that in your calculator is you have to press second and then the trig button, right? So for instance, in number 7, from x, you're doing sine because it's opposite and hypotenuse. And you're doing the inverse sine, so you have to hit second sine and then the fraction. All right. So just as a quick example here, I'm going to use tangent because from angle x, I have the opposite side and the adjacent side, so that's TOA, tangent, right? And so here's my setup. Tangent of x is equal to 17 over 11. And since I'm solving for the angle x, I'm going to do the inverse tangent of 17 over 11. Okay? And again, your calculator should be in degree mode. Take a look at these examples here. All right? And hopefully you can tell how we split the work, all right, and try to follow along. If you have questions on these problems, please shoot me an email. All right, in 8.4, we're going to look at angles of elevation and depression. All right, angle of elevation is when you're looking straight across, right, and then if you look upwards, right, the angle that's formed is the angle of elevation, okay? The angle of depression is if you were to look down, okay? Notice it's not the angle inside the triangle, right? And so what kind of angles are these, right? Well, this would be the angle of elevation from this perspective, right? And if these are parallel, right, we learned about alternate interior angles, okay? So these are actually congruent. The angle of elevation is congruent to the angle of depression, right? So a couple of word problems here for you to go through, all right, read through here, okay? These are both angle of elevation problems. In number 4 and 5, these are angle of, these are angles of depression, all right? Okay, so again, from the top of the tower, the angle of depression, right? So if you were to look across and then look downward, there's that angle of depression, but again, it's congruent to the angle of elevation over here, all right? And then we apply SOHCAHTOA here, okay? Again, from the angle, right? 80 over x because opposite over adjacent, all right? This one we use sine because the angle of depression is the same as the angle of elevation, right? Opposite over hypotenuse, so we use sine, right? That's why you got to know SOHCAHTOA. All right, make sure you go over this problem here. It can be a little tricky, okay? The person holding the ball is 6 feet above the ground, all right? So notice in our final answer we have to add 6, okay? So pause here and take a look at this problem more. And I would also go over this problem too. If you have questions on this, please ask. I might have to make a separate video going over this problem. And the last thing we're going to look at in 8.5 is the law of sines, all right? This applies to any type of triangle, not just right triangles, okay? So between any two sides and any two angles, all right, this relationship holds true, all right? Sine of A over little a, remember capital letters represent angles, lowercase represents the length of sides here, okay? And so when it says solve the triangle, it means you need to have all three sides and you need to have all three angles, okay? So when you look at the notes here, right, I know this is kind of filled in, but it seems like you were only given angle D, all right, and you're given F is 16. So if capital F is here, then lowercase f 16 goes across, right? Remember the side always goes across from the angle, and lowercase d is over here, okay? And so I think what we did was we solved for the angle F, all right? So sine of 88 over 21, those are the D's, right? Capital D over lowercase d, sine of F over 16. And how do we solve a proportion? We cross multiply. So 16 times sine 88 equals 21 times sine of F. Now, don't do this part in your calculator where I'm circling, okay? You're going to write this all out, and then at the very end, you're going to do all of that together in the calculator, right? I might also have to make a separate video on the order that you should do this in, okay? But the reason we do all of it at once at the end is you get a more accurate answer, okay? So once you figure out angle F, well then here in green, if you know a triangle adds up to 180, then you can figure out angle R, and you need angle R because now you need to do it again, right? You can, because we need to figure out side R, all right? So you have to do the law of sines yet again. And same thing here, in example 4, I think you're only asked to solve for little e, and so we have to do the law of sine once again, all right? Yeah, I'll try to make another video, but if you have questions, again, please do shoot me an email.